Okay, so we're video 33, I believe, in 105. We're continuing what we were talking about last time, which was identifying the end behavior of a polynomial function. Okay, so it belongs together with video 32, this last part of what I'm doing right now. So let me get my pencil. Here we go. No. Hold on a second. Pencil. Okay, so polynomial functions is what we're talking about. Polynomial. Polynomial functions. Okay, continued. Now, let me give you two questions based on what we were talking about. We're talking about the end behavior. Okay, end behavior. Let's say I give you an example of f of x is equal to minus 4x to the fifth plus 6x to the fourth plus 2x. That'll be one example, another example, and let's say I give you an example of as follows. What if it is 3x to the sixth plus 2x to the 5, etc. So here's our leading coefficient, and here's our leading term and our leading term, right? So look at the leading terms. Look at the leading terms. So make sure it's in order. 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 And then look at the leading terms. So here's our leading term, here's our leading term, these two questions. All right, so now this is negative, the coefficient is negative, the coefficient is negative, the coefficient is negative, and the exponent is odd. Okay, what's that going to get you? That means the end behavior is going to look like this. Just as you saw in video number 32. Okay, what about this problem? Okay, let's do this problem over here. In this case, the coefficient is positive. The coefficient is positive, and the exponent is even. Coefficient is positive, exponent is even. What's the story there? Positive and even. It looks like a W. Here's a picture, and looks like basically whatever happens over here wiggles around, but it looks like eventually a W. This is the end behavior. Okay, that was question 2. Question 3. What if you had a g of x equals 1/4 times 2x minus 3 to the third power times x plus 4 to the second power. And I don't care what happens after that. All right, so And the question is, again, let's go get the end behavior. Right? So the question is end behavior. Okay, so scrap paper, we need to find out what's the leading coefficient. Scrap paper. What is the leading coefficient? What's the leading coefficient and exponent? So now, how do we get that? Here we go. Here's the x. It's going to be raised to the third power. Oh, I'm sorry. I forgot one more thing I want in there. One more thing that makes it a little bit harder. I meant to put in an x over here. Okay? Okay, so there's an x here. And that's the question. So what's the leading coefficient and exponent? So then x times x to the third, that's x to the fourth, right? It's going to be x times x to the third, x times x to the third, and times x to the second. X to the second. So that's a total of the x to the second, I'm sorry. So that's a total of x to the sixth. That's x to the second. So it's a total of x to the sixth. So the exponent is going to be x to the sixth. What about the coefficient? All right, the coefficient is going to be 2 to the third, right? 2 to the third, which is equal to 8. 2 to the third, which is equal to 8. And then 1/4 of 8. 1/4 of 8 is equal to 2. So the leading coefficient, here's the exponent, and the leading coefficient is 2. So therefore it is positive, and this is the exponent is even, right? So it is the coefficient is positive, and the exponent is even. So end behavior, that's the question. Here's the answer. It looks exactly like this case over here. It's exactly this. The answer looks like coefficient is positive, and as the coefficient is positive and the exponent is even, we get something that looks like this. That's the end behavior. Okay, so you can get it in a complicated way. It can look a little complicated, all this, and you've got to figure out the leading coefficient, and you've got to figure out the exponent, if it's even and odd, and then you can answer. Once you figure out it's coefficient positive, exponent even, you know that it looks like this. All right, that's it for this video.